Welcome to this brief but educational presentation on tolerance rings, your flexible fastening solution. We are USA Tolerance Rings, the sole manufacturer of tolerance rings within the United States. So, just what are tolerance rings? Well, tolerance rings are circular fasteners used for joining cylindrical parts. They are typically shaped like a letter C, and they have a gap between each of their ends. They have waves or corrugations on their circumference spaced accordingly, and the waves or corrugations have a particular height to them. They support innovative and flexible designs by providing a fastening alternative to keys, pins, adhesives, D-shafts, threads, and splines. They can allow for the joining of dissimilar materials, such as when you're trying to connect a plastic cylinder to a steel cylinder. They compensate for thermal expansion and contraction, which is critical in cases in which the components have different coefficients of thermal expansion. They can mitigate radial misalignment, especially when bearing pockets are not collinear. They allow for the relaxing of machining tolerances, thus reducing the cost of producing parts. There are basically two types of tolerance rings. The first type is the AN or ANL type. The ANL type is just a lighter duty version of the AN type. The AN type has its bumps or waves on the inside circumference of the tolerance ring, and they are typically inserted into a housing or bearing pocket ID. The second type of common tolerance ring is the BN type, and this has the bumps or waves on the outside circumference of the tolerance ring, and they are typically slid into place onto a shaft OD or the outside diameter of the inner component. While traditional methods are commonly used for mounting cylindrical components together, tolerance rings may be the optimal solution for projects requiring a balance of durability and flexibility. Traditional solutions consist of press fits, the use of rubber boots, O-rings, or plastic inserts. Both tolerance rings and traditional solutions can be used to mount cylindrical components by exerting a holding force between them. Both tolerance rings and traditional solutions can be used for mounting bearings in place. But when it comes to situations where there's a broad temperature range, or you're dealing with extremes of temperatures, tolerance rings comes out to be the clear winner. The reason for this is that rubber boots, O-rings, and plastic inserts will tend to soften up at higher temperatures, and their durometer rating can change throughout a given temperature range. At lower temperatures, they can tend to become hard and brittle. When dealing with aluminum housing, if you go with a pure press fit for a steel ball bearing, at hotter temperatures, the aluminum housing can expand at a much greater rate than the steel ball bearing. The result is you lose the press fit at higher temperatures. Not so with the tolerance ring, because the tolerance ring's bumps, waves, or corrugations act as individual springs to retain the inner component or the bearing in place. Tolerance rings can also handle temperature extremes without breaking down because they're made of special steel alloys, whereas rubber boots, O-rings, and plastic inserts can degrade at the higher temperatures. Since tolerance rings are made of steel alloys, they can also endure a variety of lubricants and harsh chemicals much better than rubber boots, O-rings, or plastic inserts. So when does it make sense to use a tolerance ring? Well, think in terms of cylindrical components. Anytime you're working with cylindrical components and your current solutions are not working for you, think about it. Would a tolerance ring make the design work? Some of the top applications of tolerance rings, they are used for mounting bearings, for the transfer of torque, stator mounts in electric motors, for mounting bushings and sleeves in place, and for the centering of components to keep them aligned. They're also used for fastening and joining components together. Tolerance rings may not be suitable for tapered bearings or heavily loaded roller bearings. There are many industrial applications for tolerance rings. Examples of some of those industries are automotive and transportation, oil, gas, solar, and wind, consumer products, aerospace, medical devices, automation, robotics, and conveyors, maritime, and the defense industry. Some common uses within those industries include bearings, electric motors, gearboxes and transmissions, steering systems, pumps and compressors, conveyor rollers, pulleys, joints, power transmission, and semiconductor manufacturing equipment. As mentioned earlier in this presentation, one of the greatest benefits of tolerance rings is their ability to compensate for differences in the coefficient of thermal expansion between various components. Tolerance rings can prevent loss of retention experienced when mounting cylindrical components such as bearings, stators, gears, and housings that have different rates of thermal expansion. Typically, when dealing with high temperature extremes, the press fit has to be so tight at room temperature that it ends up overly crushing the ball bearing, and that can cause premature bearing failure. With a tolerance ring, you can retain the bearing without the extreme forces normally encountered with the press fit and still hold that bearing throughout the higher temperature ranges. Tolerance rings allow for the mounting of bearings and other components within aluminum and zinc housings or other housings that have different rates of coefficients of thermal expansion compared to the inner components. The tolerance ring can retain bearings and components through a wide temperature range, depending on the diameters used and the particular configuration of tolerance ring selected in the design. They can even be used for plastic housings that are glass-filled. Plastics tend to have a greater coefficient of thermal expansion than aluminum and other steels. Tolerance rings can also be used for securing stators within aluminum motor cans. They will prevent the stator from rotating due to torque loads throughout the thermal and temperature ranges. Tolerance rings can mitigate radial misalignment. This can occur in situations in which there are two bearing pockets, one at each end of a housing. If the bearing pockets centers are not perfectly collinear, what can happen is one bearing is slightly off compared to the other. In a pure press fit situation, this puts excessive strain on the shaft and the bearings as well, which results in premature bearing failure. With a tolerance ring installed, the tolerance ring is more forgiving than a pure press fit and will actually relax some of the stresses and strains on the shaft, resulting in less misalignment in the case of when the holes of the bearing pockets do not properly line up. This is very important and critical for use in multiple bearing systems and with rotating shafts and electric motor applications. We've run into these situations before where a manufacturer would use a CNC machine to create a bearing pocket at one end of the housing. They'd flip the housing around, then come in from the other side and drill it out to create the bearing pocket at the other end. And what happens is it was resulting in some misalignment of the center lines of the bearings. And by using tolerance rings, they were able to relax some of those stresses and strains created for when the bearing pockets were slightly off center from each other. Tolerance rings can also act as a torque transmission mechanism. They can transmit torque between the inner and outer components. And in some applications, the tolerance ring can be designed to act as a torque slip mechanism, almost like a torque slip circuit breaker. For situations in which the torque goes above a certain point, the tolerance ring will allow for slippage. And then when the torque drops, the tolerance ring will regain its grip on the inner and outer components. When using the tolerance ring as a torque slip mechanism, the diametric tolerances of the components have to be kept rather tight, and the tolerance ring can typically hold the torque bandwidth within about 20 to 15% of a desired slip point. The use of tolerance rings for torque transmission or as a torque control mechanism can be very useful for applications involving plastic gears, pulleys, discs, sprockets, flywheels, rollers, impellers, and shafts. Reducing noise and vibration is a common design problem that engineers often face. Noise and vibration can be detrimental to rotating devices due to excessive wear, structural fatigue, and energy loss. A tolerance ring spring-like characteristic may be used to reduce noise and vibration by shifting and changing the vibrational harmonics of the mounted bearings, by minimizing and preventing resonance, or by eliminating backlash in system components. Essentially, in a vibrational system, the tolerance ring acts as a spring, so it won't dampen vibrations, but what it will do is it will shift the harmonics, it will shift the vibrational frequency of the components. The objective is to select a particular tolerance ring configuration that shifts the harmonics away from the natural frequency of the system. If it ends up shifting the harmonics away from the natural frequency of the system, you will get less noise and vibration. Tolerance rings can allow for the simplification of manufacturing processes. Extra machining steps, preserving tight tolerances, grinding, adhesive curing times, complex assemblies, and added inspections can all increase manufacturing costs. Tolerance rings can help reduce these costs by allowing for the relaxing of machining tolerances on the components. In situations that previously called for tolerances of a few 10,000ths of an inch, you can go with tolerance rings, which will allow you to relax the tolerances to a few thousandths of an inch. Relaxing tolerances like this reduces the cost of machining and the cost of labor involved with machining. Thus, the overall result is an improvement in production efficiency. USA Tolerance Rings has decades of various customer applications. Although we can't get into the specific details and we cannot disclose our customer names, here are some sample projects where tolerance rings have worked successfully. They've been incorporated in electric vehicle drive systems. They've been used as an automotive speed limiter. They've been inserted into conveyor rollers and conveyor systems. They've been implemented as part of an automotive pressure monitoring system for monitoring car and truck tire pressures. They've been incorporated into diesel filtration systems for use on diesel combustion engines to remove the diesel particulates. They've been used on commercial aircraft control systems. They can be found in defense guidance systems. They're used a lot in the oil and gas industry, especially for downhole drilling equipment and electrical monitoring sensors. They've even been used on commercial fitness equipment, such as cross trainers and various exercise equipment. And they're used on boats and ships as part of marine propulsion systems. USA Tolerance Rings empowers design success by providing alternate solutions and manufacturing options. Our responsive engineers are dedicated to supporting customers from prototyping through production. We are ISO 9001 certified and IATF 16949 certified for the automotive industry. To get started, submit a project today by visiting our website at usatolerancerings.com. On our website, you will see various tabs that say Start a New Project. Just click on that and enter all the pertinent information required in those fields. That'll help our engineers to look over your project and start our analysis to see if a tolerance ring would be suitable. We thank you very much for watching this presentation, and we look forward to working with you on your future projects.